everyone, Kai here. In this video, I will be discussing the basics of oxidation states, as well as explaining how to find oxidation numbers of atoms in an ion. Let's start off with, what is an oxidation state? Oxidation state. An oxidation state is expressed with a number that defines the amount of electrons that ions can gain, lose, or share while chemically bonding. Oxidation numbers can be shown per ion or can be shown per atom within an ion. Expect to see atoms with high electronegativity to have negative oxidation numbers like halogens and nonmetals, and atoms with more of an electron affinity to have positive oxidation numbers, including metals. Now that we have broken the ice, let's start determining oxidation states of atoms. Down here, I have a list of rules that must be followed while solving oxidation state problems. Pause the video to familiarize yourself with these rules. Let's start off with a simple ion. Let's do CaO. Calcium, right here, is in group 2 of the periodic table, making the oxidation number +2. And oxygen's rule states that it is usually -2. So that's our answer. Now, if we add those all up together, that will get us to 0. To prove that we got these oxidation numbers correct, the ion has a neutral charge, which means that both of these atoms will have to add up to 0. Now let's try FeBr3. According to our rule chart, there is no rule for iron, Fe, which means that we must skip this atom for now and move on to bromine, Br. Bromine is a halogen, which means that its oxidation number would be -1. This number, 3, right here, next to bromine, is saying that there are 3 bromine atoms. So there are 3 bromine atoms, not just 1. As a result, we will multiply the oxidation number in accordance to the quantity of the atom. -1 times 3 equals -3. This ion is a neutral ion, with only Fe, iron, left. We are able to use these two numbers and find out the oxidation number of iron. So, we don't know this one right here, but we do know that that unknown variable will add up with -3 to get 0, because this ion is neutral. So our answer would be +3. Now, when you add up +3 and -3, we can prove that our oxidation numbers are correct. Here's a tricky one. We have H2P2O7 to the -2nd. Starting on the left, there are 2 hydrogen atoms in this ion, and hydrogen will always be +1 with nonmetals, of which there are no nonmetals in this chemical formula. Multiply that by 2, and we get a total of +2. Pretty easy. Next is phosphorus, P, which we need to skip right now because there is no rule for it. And finally, oxygen. Oxygen will usually almost always be -2. So we must multiply -2 by 7 because there are a total of 7 oxygen atoms, and that will get us to 14. Now for a bit of algebra work. We have plus 2 minus 14 and an unknown variable p times 2. All of these oxidation states total up to the charge of -2. So let's combine like terms and add the known variables. We'll add them on both sides. So that would mean we grab the -2 here, we add those up, and we'll get -12. And then we'll add it over here. So we'll do, don't have too much space. Let's see what we can do. I'll do highlighter. So that now is going to be -12. And we're going to add it on both sides. Plus 12 plus 12. And that will get us to +10. And so that 10 is going to represent our 2 phosphorus. So we'll have +10 up there. Finally, we have to divide the 2 phosphorus. And now our oxidation number for a single phosphorus atom is +5. Now, that just wraps it up for today's video. I hope you guys learned something new. I'm Kai, and I'll see you in the next video.